Before moving on to shading, lighting, rendering, and comp, there is one more thing I want to talk about, and that is all the various considerations you ought to make before sending out that final simulation. Thus far, we've been previewing everything around 50 million voxels. And if I go to this Pyro import right now and I middle mouse, what you'll find is that we're just around 50 million. And I'd say that whenever you're just testing out settings and you're trying to get things dialed in, that's about where you want to be at. However, for the final quality, we want to be about 3 times the number of voxels for each field. So that means that we want to be somewhere around 150 to 175 million voxels. And typically within production, that is a good number for a final quality simulation. Now, many people, what they'll do when they get to the final simulation quality is they'll pick just some kind of random number, they'll hit sim, and they just kind of see what happens, right? And that's really not the best way of going about this, because if you do that, then you're likely to run into problems with your computer crashing overnight. Perhaps it'll take too long and you get too close to a deadline. And also, these cache files do get pretty large in size, and it doesn't take much of a difference in that division size to take a 1 gigabyte file and transform that to a 10 gigabyte file. So you really have to be careful about how you set this final simulation setting, or at least intentional about how you go about it. Don't just pick something random. So let's go here to the object level right here, .NET, at 0.0075, that's around 50 million voxels. And also notice how I picked a frame that's 145. So we're further along in the simulation. If I go to, let's say, an earlier frame, let's say frame 24, right? And I middle mouse the simulation at this stage, notice how we only have 20 million voxels. The sparse Pyro solver, it expands over time. And that means that as the simulation progresses, so too does our voxel count. So in this particular simulation, it takes about 100 frames for it to get going. What that means is that at about 100 frames or about 50 million, that's good. Let's go here to the smoke object and say 0.005, like that. And I already know ahead of time that this is just about the number we want for the final resolution. But just to test this, and you know, if you have the time, it is worth the test. Let's do up to frame 100, save that to disk, and see what our voxel count is now. At frame 100, we have about 180 million voxels. And so this is probably a little bit too much, a little bit more than what we need. Let's go back to the .NET and change this to 0.0055 right there. And this should be about what we're after. Maybe 0.006 if you want to be safe. So we'll just do that. Why not? 0.006, and I'm not going to cache this out again. This is going to be about the right area that we're after. But as long as you have a general aim at this voxel count, that's the idea. That's the intention. Okay, so another thing to think about as well is the amount of memory that you're using. I'm going to press Control-Shift-Escape on Windows. This will bring up my PC specs, right? And on this particular machine, I have 64 gigs of RAM. As this simulates, I'm right around 50% usage on that RAM, and it fluctuates. So if you're to actually look at this while it's simulating, it's going to go up and down, probably give or take about 5 to 10 gigabytes worth of memory. Now, if I ever reach the very, very top here, that's the full 64 gigs of RAM, I risk crashing Houdini and potentially my entire computer. So if you're doing something overnight, you want to keep that in mind. Keep in mind that your simulation will fluctuate in the amount of memory that it uses. And at any point, if it reaches that top, then you might crash. So it's a good idea to give yourself a lot of extra room so that you don't accidentally crash overnight. And right around 50% here is totally ideal. It's not going to shoot all the way up to 64 out of nowhere. So I think that this is an ideal situation. Now, depending on your memory as well, you might have to, adjust to a lower resolution because of this, but, it just depends. So that is one consideration. And another thing as well is the actual file size. So if we go here to the Geo, PyroSim, let's go down to frame 100, which is right up here. We're at about almost a gigabyte per file size. And remember, frame 100, this is what we judge things by, because by then the simulation has cooked up quite a bit. So at about frame 100, it's just about a gig. That's pretty normal, I'd say. But just keep in mind that it doesn't take that many frames to reach a lot of space on your hard drive. I mean, I think for this simulation, we'll end up doing about 720 frames. So that's 720 gigabytes worth of information that we need to have room for. So just keep that in mind. Also keep that in mind if you're working on, let's say, a server or something like that, that you have the space there ahead of time. Okay, so we've talked about memory, we've talked about file size, we've talked about how to get a general area when it comes to this voxel count. Once you've thought about those things, another thing to think about is the number of frames that you need to use. In this case, what I'll eventually do with this fire is I'll take the playback speed and double it. And so that means I'm playing this at 60 frames a second, or if I'm rendering this out, I'm going to render every other frame so that this appears to move twice as fast. Now, why am I doing that? Well, I'm doing that because it looks better. It's a little bit more like reference. If you look at reference, fire moves really quickly. And the nice thing about doing it like this through the frames versus if we go here, the time scale right here, is that with this slower time scale, it's going to give us a more accurate result with the PyroSim. And then once we double the speed using the playback frames, then we don't sacrifice any quality within the solver, any accuracy. And so that's why I'm not relying on this time scale to do that. Instead, I'm just taking double the number of frames. And the nice thing about that too is that if you ever need to change, like let's say some fast motion, slow-mo kind of trick stuff, then at least you have some extra frames there available just in case that becomes a request. So anyway, that's why I'm doing it that way. 720, by the way, is something I figured out. If we have 30 frames per second and we need 10 seconds of footage, okay, so that's 300. We're doubling that, and I'm leaving an additional 120 frames for the simulation to get going. So don't forget to add a few frames in there for the simulation to start up, and then we have 10 seconds once it's going. So that's 720. Don't forget to also cache out your Pyro source for 720 frames. I went down here as well, changed that to 720. And then once you have all that set up, go ahead and cache this out. In the next video, we'll talk about shading, rendering this out, a few little comp tricks, and then we'll call it good.